Hello everyone. So today we are going to cover add one row to tree. We are given a binary tree with an integer value and the depth of the tree where our values has to be inserted. So let's understand this problem with an example. Here is our given binary tree example. So the first root element is considered to be at the level or depth 1 and the second level is going to be depth 2 and goes on till the last level where depth n. So now we are given an integer value v and a depth d. We have to insert nodes of value v at the level or depth 2. So now our job is to insert a level here that is at depth 2 with nodes of value v. So once we have inserted a level here, the remaining or rest of the children will continue as its children. So let's have a root node 4. This is of depth 1 and now we have to insert our nodes of value 1 at depth 2. So our values will be inserted as its left and right children. So once the level at level 2 or depth 2 our given value nodes are added, the rest of the children are going to be its children. So now 2, 6 and then its children 3, 1 and 5 are added to the rest of the tree after adding the level. So now how are we going to approach this? This problem can be approached using any of the traversal technique, that is either BFS or DFS. In our channel we are solving recursive problems recently, so now I plan to solve this recursively. By using the same idea you can solve it using either DFS or BFS. You can find the code in my description. So let's start. So here the basic condition we are going to check is if depth is equal to 1. If depth is equal to 1, then the root node itself has to be the value given here. So now if depth is equal to 1, we are going to create the node of value given and point its left children towards the root of the node and return the head or root as the newly created node. If not, if the depth is greater than 1, then we are going to iterate and find its previous level. Why previous level? Because if depth is equal to 2, then once the nodes at level 1 are going to hold the newly created tree nodes with values given. That is, if depth is equal to 4, here it is depth 1, depth 2 and depth 3. Finally the level 4 is going to have the values attached to its parents. So where are the parents? Parents are at level 3 or depth 3. The same way we are going to iterate and find the previous level to the depth. That is, if depth is equal to 2, we are going to find the level d minus 1, that is depth 1. So once we reach our depth minus 1 level, we are going to hold its left and right children in temporary values and create new nodes and attach them to the particular level and then further add its children to the newly created nodes. So now let's go for a dry run. Now we are pointing at level 1. So this is actually depth minus 1. So depth, we have reached depth minus 1. So now we are going to create temporary variables. In temp, I'm going to hold my left children of the given root node. So now I'm going to create a new node 1 and attach as its left children. And once it is attached, I'm going to attach this T1 to my as the left children to my created node. That is, it is going to point to. Same way, I'm going to create a new node 1 and attach as its right children, wherein my 6 was stored in a temporary variable. So once this is done, I'm going to point 1 to point at 6 so that a new level is created and further its children are added. This algorithm actually runs in big O of n time complexity and big O of n space complexity. So let's see the code now. So as part of recursion, I'm gonna have a helper method. Let me name it as insert, which is going to hold the value of given value v, and node, and depth. The current is going to point at the current depth, and d. So now I'm going to check if my depth is equal to d minus 1. If that is the case, we are going to insert the children. If not, we are going to move to the next depth or next level. So if depth is equal to n minus 1, then create a temporary node. As we have stored root.left in temp, then root.left is actually going to be a new tree node, which is of given value. So once it is created, we're going to point root.left to the temporary node because we have stored roots left to temp. Now it's time to save temp. Yes, we just swapped. Same way, I'm gonna have my right child of the given root as a temp. Now node.right is equal to new tree node of given value. Again, node.right is equal to temp. So yes, we have connected them properly. That is, if we reach the level t minus 1, then we are going to save its children in a temporary node and assign a newly created node and then its children as the root's children. If not, we are going to iterate till we reach the level depth minus 1. So we're going to call the same function with values same, but going to explore root.left, and if every level it is going to increase its depth. So depth plus 1 and the given d. Same way, we are going to call root.right and depth plus 1 and given d. So it iterates every time and call and explore its children until it reaches the level depth minus 1. So if we found the levels and added the values and further iterate, it has to stop calling the function, right? So we need to add the base condition. If it reaches the leaf nodes, that is the root is equal to null, then simply return. Yes, now our insert function is done. In our main method, we are going to call the function, but before that, we are going to check if our given depth is first level itself. Then that is the case, we are going to create a tree node of given value and attach this as the root node. That is, its left is equal to given root and return here. If not, if it is not d is equal to 1, then we are going to call the recursive function 1 depth and d. Finally return root. So now let's run. Yes, let's submit. Yes, the solution is accepted and it runs faster than any other solution submitted. So thanks for watching the video. If you like the video, hit like and subscribe. Thank you.